Let's begin. Let us begin. It's my privilege to welcome you to the University of Tennessee Nuclear Engineering Department Colloquium Program. Today's speaker is Mr. Bill Brumley, who is the manager of the Y-12 Site Office of the National Nuclear Security Administration. Bill has been at Y-12 since April of 2000. Prior to taking this position, he was the acting assistant manager of defense programs for the Department of Energy's Oak Ridge Operations Office. Before arriving in Oak Ridge, he served as the deputy assistant manager for national security at the Savannah River Operations Office in Aiken, South Carolina. Prior to that, he was employed by the Department of Defense at the Charleston Naval Shipyard. Bill is a graduate in nuclear engineering, a BS graduate from North Carolina State University in 1970. The title of his presentation today is National Nuclear Security Administration, Protecting America's Future. Bill, welcome.
There was a presentation given by Buddy Connor, one of our deputy general managers at the site on the contractor side here a few weeks ago. I think his talk was much more internal to the plant and exactly what we do. Hopefully this presentation will put things in a little broader perspective. So let's see if we can get going here. A lot of people get confused about what the NNSA is. We are still part of the United States Department of Energy, but several years ago Congress decided they didn't want the weapons people being distracted by a lot of other things within the Department of Energy, such as energy regulation. So they created this separate, we call it separately organized, sometimes semi-autonomous agency or administration. And its purpose is to oversee the nuclear weapons complex, 4 production plants, 3 design labs. We do report NNSA directly to the Secretary of Energy. Currently we're headed by Ambassador Linton Brooks, who was recently nominated by the President to serve in this capacity. And myself as site manager, I report directly to Linton Brooks. What they really wanted, Congress, was to have people that woke up every morning and when they're on the way to work, their thought was national security and not distracted. So that's what we're really all about. Our mission is one, to maintain safe, secure, and reliable nuclear weapons. Some people debate whether this country needs nuclear weapons or not. That's not the purpose of Y-12, but as long as it is the administration and this company's policy to maintain nuclear weapons, our job is to make sure they are safe, secure, and reliable. We also look to strengthen the United States through the military application of nuclear energy, and I'll have another slide in a minute. A lot of people don't realize that a sizable fraction of our work at Y-12 today is actually reducing the threat of global terrorism by the elimination of weapons of mass destruction. And for us, that's primarily on the nuclear side, not chemical or biological. Probably some of the other missions, one is to detect, prevent, and reverse proliferation of weapons of mass destruction. That's really the focus on what we call the NN. I apologize, I didn't bring our LOA, which is the list of acronyms. Being a federal employee, and particularly at Y-12, we can speak whole paragraphs without ever using a word. So pardon me when I do slip back. But mainly our focus on the NN side, non-proliferation, is the fact we are the uranium center for expertise. Bad guys have the technology to make uranium weapons. What they don't have is special nuclear material. Our ability to monitor, detect, handle is why we are such a focus there on that side of the house. We also provide the Navy with feedstock. We don't actually manufacture the fuel. We ship it to their core vendors who turn our uranium into fuel for our submarine core. We also, not shown in this slide, but we also, a lot of folks don't realize we're actually blending down some of our highly enriched uranium. We don't. We blend it part way. We send it to USEC, the U.S. Enrichment Corporation, and they blend it down to levels 4 to 6% of it are available than to our civilian reactors. The overall nuclear weapons complex, again, as I said, is composed of 4 major production plants, 3 design labs, and 1 test site. Currently, the U.S. has a ban on testing, but we have to maintain that site in a readiness. And I'll just walk over, because it's just a little easier to point out on the chart, of these 4 major production plants. Where I came from first, the Savannah River site, the goal, I can use the pointer.
Yeah.
Whoop. That works.
There you go.
The Savannah River site, their prime mission right now for NNSA, with respect to the weapons program, is tritium production and recycle. There's also a mission at Savannah River on the NN side of the house for plutonium disposition. But in the actually nuclear weapons complex, the Savannah River site mission is tritium. Kansas City plant, their basic function is to manufacture all of the non-nuclear parts. Nuclear weapons are very complex devices. They have all sorts of plastics, electronics, firing, fusing, arming sets. All of the non-nuclear components just about are manufactured at Kansas City. Y-12, our business is uranium and nuclear weapons secondaries. All the weapons in our stockpile today are basically 2-stage, a primary, secondary. Typically the secondary is thought of as the thermonuclear component. Our business is to manufacture or remanufacture nuclear weapons secondaries. We haven't made any brand new ones since the late 80s, early 90s, but we're currently in a program of refurbishment where they come back and we take them apart and inspect them and then put them back together. The other major facility is Pantex in Amarillo, Texas, and their function in the complex is to actually do the assembly and disassembly of the weapons themselves. They also do the manufacturing, machining of the high explosives that go into the weapons program. But you can see that's where that it all comes together. Shipments to and from the military tend to be from Pantex. The 3 design labs actually do the engineering work and specifications on the work we do. And we have Los Alamos, Sandia, both of those in Albuquerque, New Mexico. Los Alamos is actually a little north up near Santa Fe. And then out on the West Coast, Livermore out in California. But that's how the fundamentals of the whole nuclear weapons complex comes together. One point I would make is every piece of it is absolutely vital, and particularly here for us in East Tennessee, Y-12, we are a unique national asset. If we lose any part of the weapons programs here, we lose the whole complex in a matter of time. This is the one overview chart that we use a lot to talk about what we do at Y-12 in the big picture of things. On this side of the house is the classic, what we call defense programs or weapons programs. We actually manufacture nuclear weapons components. In fact, there's at least one component in every nuclear weapon that's ever been fielded came through Y-12. As I mentioned earlier, we manufacture fuel for the Navy. Interesting down here, dismantlement and quality evaluation of weapons. And for our business, it's on the nuclear weapons secondary side. When these things were manufactured early on in the program, nuclear weapons were designed to have maybe a 5 to 10 year lifetime. Now some of them have been fielded for up to 30 years. And in fact, we do a very careful disassembly, in our case of the secondary, looking for signs of aging. We want to understand how these things do behave over time, and that's part of our quality assurance program. There's also a number of unique alloys and materials, some uranium-related, others not, that we manufacture at Y-12. This is about, currently today in terms of budget, about 2/3 of what I do, of about 2/3 of $700 million a year. A fairly sizable program. On the other side of the house, got to get used to this pointer. On the other side of the house, the non-proliferation side is about 1/3 of our business, and again, it's associated with perimeter monitoring. We have to protect our uranium. We can help the Russians protect theirs. storage and handling, accountability, detecting diversion of uranium. We have extraordinarily large ton quantities, and we have to be able to detect if anybody is diverting even a small fraction of that. Probably some of the leading edges of cybersecurity. So much of what we do is classified, as you might expect with the design of nuclear weapons. We have to have the ability to operate and be able to exchange that information, at the same time protect it from those who might want it. And again, the defense side of the house, about 2/3 of our budget, and over here on the other side, non-proliferation, about 1/3 of our budget. Interestingly enough, in FY03, for the first time, our actual throughput of the plant is going to be very close as to which will win out, but it's right now just about a 50-50 split, that of the uranium that's going through our plant, about half is associated with defense programs, and about half is on the non-proliferation side of the house, either going to USEC, or some people are surprised that we actually sell uranium to foreign customers. We sell to France. Won't go there. Argentina, who's building a reactor down in Australia. We sell to Japan. We have negotiations underway with South Korea as we speak. Y-12 itself is as I said earlier, is an absolutely unique national asset, and we are investing in new technology every day. The reality is we haven't made major upgrades in technology, processes, or facilities in 30 years. And I believe I have a slide later on in here to talk about some of our modernization efforts. Our function is to maintain a safe and secure manufacturing facility. Some folks have actually characterized Y-12 as we're really not that complex. It's really a chemical processing plant. We have the ability to recycle uranium from floor sweepings back into pure metal, all the way to a foundry where we can do forgings and castings, and a machine shop. The thing is, we just do it with unbelievable precision and quality. And unlike some industries, we actually do it with highly enriched uranium. Again, I think we've covered the non-proliferation issues. We have a very aggressive modernization plan undergoing at Y-12. As I said, we haven't had any major new facilities in probably 30 years. We have the first piece of that, a facility we call our purification prototype, which is manufacturing a non-nuclear material that goes into weapons. We have our HEU, high enriched uranium materials facility, which is a storage vault to be able to consolidate and provide even more protection to our material. We're aggressively recruiting, and Kathy, you probably know the numbers, but I think it's well over 100 graduates, I think, now that we've hired, and that's after the last 10 years of just occasionally onesies and twosies. Right. So we're just very excited about where we're going. Again, I think I've talked part of these, that our current mission is production and refurbishment of weapons components. And for us, that really means nuclear weapons secondaries. There's some other things that we do, but that's the key main. The other is storage and protection of special nuclear material. We are the Fort Knox for the United States for highly enriched uranium. By and large, across this country, if it's not deployed in a weapon, it is most likely stored at Y-12. There are, as you might imagine, some of the other design labs and production complex may have small quantities, but in fact, most of the HEU is here stored at Y-12. We do dismantle weapons and recovery. I think it's no secret to this group that we haven't actually had any enrichment in a number of years, to the higher levels. So we do recover material. This new weapons, as I talked about, preventing the spread of weapons of mass destruction, and we really probably should be a little more careful on these slides because we're really here talking about nuclear weapons of mass destruction, improvised nuclear device kind of deal. We also provide a fair amount of support to national security needs. As you might imagine, if anybody across the country, including some of our three-letter agency friends, if they want to know about uranium processing technology, how you detect it, how you sample, we are the expertise in this country on uranium. So there is a tremendous amount of support we do for others. It is, in fact, a very exciting time for Y-12. I have been there now for about 3 years, and our vision is to really reshape the complex. There are sort of 3 principles we're using. Early on, I said, if we don't need it, let's tear it down. We have a lot of old buildings, facilities. By the end of FY03, over the last 3 years, we will have torn down about 120 separate structures, some small, some big. That's actually about 12% of all the buildings on site. As you might expect, we got some of the easier ones first, but in fact, that's still a fairly impressive number to tear down 10 or 12% of all your buildings. The key upgrades to that, one is if you don't need it, tear it down. But then the actual modernization strategy is on 3 parts. First of all, if you can reuse an existing facility, modernize it, put it in place, you ought to do that. The final strategy is to build a brand new facility. You really don't want to do that unless it's the absolute last option. So we'd much rather be able to reuse an existing facility if we can and meet all the security and safety requirements. A new facility is our last resort. Let me back up. I lost my mouse. Where'd the mouse go? Did it disappear?
No, let me have it.
All right, where's the mouse?
Give it to me. Let me try it.
I don't see it.
Well, it's got a mind of its own.
Oh, there it is. We found it. This special materials capability, there are a number of materials we use at Y-12. One of those, beryllium oxide, which we do make certain components out of. We haven't had the ability to make new. We do have ability to make onesies and twosies, but in terms of production facility, we don't. Beryllium is actually one of the more hazardous things we deal with. We have a number of people on site that have been diagnosed with chronic beryllium disease. A number of others are sensitized to that. In fact, it is one of our most serious health issues. We have a very aggressive program with a series of smaller projects to modernize, improve ventilation, improve work control. But we think the final answer is a new modern manufacturing facility that isolates the worker from the beryllium, just like historically we've isolated workers from plutonium and uranium and other things. We forget about the simple things. It's a 50-year-old plant. In some cases, we have our new buildings that are 30 years old, but they're being let down by utilities, sewer lines, steam lines that are rusting through. So we're really looking long-term at just a major upgrade to the facilities. Should have inserted another chart here we didn't do. We have a very large protected area at Y-12. It's the most secure area of the plant, surrounded by the double layers of chain link fence, all sorts of detection. You don't get into that area unescorted without a Q clearance. Most of the people in there that work are going routinely, even like myself. We have to go see a psychologist once a year. Health, physical once a year, obviously drug testing, all of that stuff. It's a very secure facility, but it's also much larger. It was designed and built over the years to support the number of weapons we had to manufacture during the 80s at the height of the Cold War. And in fact, we believe today we can have a much smaller manufacturing area. We're talking a little bit about this here, about investing in new technologies, metal processing, chemical processing, machining. We're having to change the way we think about from a production complex that was to produce large numbers of, exactly identical items to a new technology that now thinks we'll be able to have to make smaller numbers, but in varied types. Instead of supporting, there are currently 8 active weapons in the nuclear weapons stockpile, and instead of being able to make a large number of any one of those, we really need to be able to make a small number of any one at any time. Testing, inspection, validation. That's really today what we're all about. We're not designing any new weapons. Our ability is to make sure, or our key is to make sure we have the ability to understand the existing ones, look for signs of aging. It's amazing, and I think this is where I'll take my little diversion that Kathy and I talked about. For us, you see ceramics, materials, polymers, characterization, and in a lot of these technology areas, I haven't mentioned much about nuclear engineering. And it was just one of these kind of things that flashed on me when I was putting this presentation together and asked to do a talk for the UT Nuclear Engineering Department.
Bill, that's because all those topics come under the heading of nuclear engineering.
Well, let me tell you, I don't believe there's really such a thing as nuclear engineering. I think it's general engineering with specialties in math, physics, heat transfer, and all the others. But in fact, if you really think about it, when you get into nuclear engineering and in the commercial side of the house, everything is trying to, for your neutron economy, get the thing to go critical, stay critical, get the maximum amount of burnup. And we really depend on the other disciplines, whether it's material science, structural, for your safety considerations. Any job is to make it go critical, and then all the other disciplines help us keep it safe. At Y-12, it's almost the reverse of that. The nuclear engineering aspect of to making a weapon function has already been done by the design agencies. Our job is making these materials, metallurgy, whether it's making metal components, ceramic components, plastics, all of the structural things we have to do, the machining. It's a very general manufacturing process, but the key thing that we depend on our nuclear engineering is to keep it safe. The last thing we ever want to have happen is a criticality. So it's kind of flipped. From the commercial side, the focus is on nuclear engineering to make it go critical, and everything else supports that to keep it safe. At Y-12, we do just about everything else, but our real focus on the nuclear side is to avoid a criticality to keep us safe. Probably covered most of this. In engineering design and nuclear processes, you can read those as well as I can. Wireless technologies, process control, and automation. We're probably looking at that, but it's kind of in the role of a site manager. I am responsible for everything, not just the production, but safety and security. And I can tell you one thing from a security standpoint, this wireless technology is an absolute disaster. We're not, that's one of the things we're looking at, but in containment systems, this really gets back to some of the things we're talking about, looking at beryllium, finding ways to handle it just like we would handle plutonium. Robotics, process automation, we're still at Y-12, we're very much a machine shop. We're getting more and more into the remote setups and numerically controlled machines, but we've got all of this fancy electronics and many times driving existing old machines. Still requires a tremendous amount of setup by operators and calibration. Long term, we really need to go to a much more automated plant. We will still, though, have to have the ability, onesies and twosies, to make specific items or components. One of the things that I don't think we put on our chart is something we call JTAs, test assemblies, that in the absence of nuclear testing, we build a number of devices designed specifically to not go critical. And so for those things, we have to build extraordinarily high fidelity units. They look very similar to the actual designs, but as you might just in a university, you got to have test ports and all sorts of other ways to monitor what's going on. And so that's still almost a onesie-twosie hand-manufactured capability. So even though we're going much more toward automation, one of our challenges is to maintain the skill of craftsmen that can actually do some of this extraordinary machine work. Computational sciences, I sort of joke, seem like we're one of the few people that don't have a supercomputer. But in fact, we're pushing much more towards a model-based manufacturing, being able to go straight from the design drawings to manufactured components, process simulation to understand how our plant really works, interrelationships, bottlenecks to help improve production, information management. We're spending a great deal of time and effort archiving old data from the weapons program and disassembly. Some of the things we do right now is we are taking apart weapons. We have the capability to do classified video, so folks at the design agency can actually look sometimes as we take these things apart. Nuclear safety, two parts of it, facility safety and criticality safety. Crit safety is one of the things I'm very worried about long term. We do spend a lot of time teaching people how to make things go critical. We don't spend a lot of time teaching people how not to. And most of that is really not based so much in classroom, but on actual real-world experience. And so one of the things that we're looking at, haven't found some viable candidates yet, but we've certainly been looking at a number of places, is to, and I'll do a sort of a plug, looking for that top 1 or 2 percenter who has a strong dedication to national security, doesn't mind working in a nuclear weapons complex, but might be willing to dedicate the next 6 to 10 years in actually gaining real production experience, not only just here at Y-12, but Los Alamos and potentially the French, Japan, even, it's amazing the access we currently have today to Russian facilities. But one of the things that's going to be absolutely vital is people actually have experience in these plants and analyses, and you got to understand how the work is performed, not just the calculations that keep it safe. And the only way you can get that is by experience. You just can't go to school to learn that. So that's one of the things we're looking at on the crit safety side. If you think about, coming into the nuclear weapons program, one of the last things you'd expect to do be go to Russia. But actually some folks on my staff, one of them has been to Russia, I think 6 times in the last year. He's actually what we call one of our transparency monitors. I mentioned this non-proliferation. Some of you may be surprised to learn that Russia is actually taking material, enriched uranium, out of their weapons, down-blending it, and sending it back to the U.S. where the USEC is turning it into commercial reactor fuel in this country. It's really sort of the plowshares program. But and so we have people over there that go actually monitor that to make sure they're doing what they say they're doing. And yet, just like we wouldn't want them in our facilities learning about our weapons program, so there's some restrictions there. But in fact, we have a extraordinary good relationship. Also under this program, and this may surprise people, we're in the midst of negotiations, but sometime we hope over the next year, we will actually purchase some highly enriched uranium from Russia. It won't be a large quantity, it won't be a significant fraction of their inventory, but just the fact that they're now willing to start taking some of their HEU, shipping it to us as HEU, that will then be used to fuel in the U.S. Some of our reactors that currently operate on HEU. I think the ATR out in Idaho may not be no longer a candidate, but there are a number of reactors in this country that do run on HEU and will have to for a number of years. And so we can use some of their uranium in those applications. The other thing I mentioned to you that I talked about, we are shipping material to Japan, France, and Argentina. That's part of our RERTR, Research, Evaluation, and Test Reactor, I believe the acronym. But across the world, there are a lot of reactors that are operating under 93 or 97%, I think still under 97, most are 93, but highly enriched uranium. And that uranium itself, particularly in new fuel, represents a terrorist target. If they could get their hands on that material with enough time, they could make a weapon out of it. And so one of the things that we're doing, there are some designs out there for fuel that the reactors will still run on low enriched, and sometimes we call it highly enriched, low enriched, but 19.75%, which is a less than 20%, which is generally considered the borderline between high enriched and low enriched. And so we're blending some of our material down to 19.75%, so these countries then can avoid that proliferation target. I think I've probably already covered some of these areas. This is the HEU transparency. That's the blend down of the material. We've got to make sure they're doing it right. MPC&A, that's material control and accountability. That's where we're actually helping the Russians protect their material. Don't think we have in this presentation, but I do have some slides of what before, I mean, our place is like a Fort Knox at White 12. It's not an easy place to get into. Many of the Russian facilities were very rudimentary. I mean, they had windows that didn't even have bars on them, just maybe a single layer of chain link fence if they did, no real detection systems. So we're, and many people are concerned that the real threat of weapons of mass destruction, particularly uranium, is not that anybody would steal it in the U.S., but there are other third world countries, and although Russia is not a third world country, in many ways some of their technology is very backward from their old Soviet state. They didn't need to worry about protecting this stuff. I mean, when they came near it, they didn't need to, they'd be shot. So, but in today's world, that's not the case. So, Nuclear Cities Initiative, this is just sort of a Y-12 and Oak Ridge, well, not Y-12, but Oak Ridge, been very successful in turning K-25, the old diffusion plant, now called East Tennessee Technology Park, and trying to return that to commercial use. The Russians have a number of cities, but even more global than Y-12, which is, you know, that was, Oak Ridge was basically a uranium plant with the lab enrichment out at K-25, and Y-12 the fabrication plant. Russians had whole nuclear cities. They had reactor separation, enrichment, all in one location. So we're trying to help them with those. HEU and plutonium disposition. Export control. That's kind of an interesting topic. You wouldn't think folks here at Y-12 would be worried about it. We're actually helping train Soviets and others that are on the borders at being able to identify dual-use materials, things that conceivably could be used in construction of a centrifuge, you know, aluminum tubes, those kind of things. There's a lot of technology that could go either way, and so we're helping create manuals and train people on what to look for. I think I've already talked about this one. Here's some people, some photographs over in Russia. This is part of the folks doing the transparency stuff. Don't see any of my folks over there. These pictures. Probably covered this one. Oh, that's just an interesting photograph here. Anybody know what that is? Actually, it's just a chunk of very hard steel. One thing the Y-12 did was actually machine that, and that's the nose cone of the B-61 Model 11, which is one of the Earth penetrator weapons. think I've already talked a little bit about this in terms of engineering support and why technology is going to be so important to us. If I look at Y-12, it is hard to find a specific discipline there. There's probably not an engineering or scientific discipline that we don't touch in one way, shape, or form. And not just Y-12, I'll probably get to the whole Oak Ridge community here. Career paths from basic research that's done over an ORL and spallation neutron source all the way to applied engineering at Y-12, manufacturing and production. There is just an extraordinary environment here in East Tennessee, and particularly the Oak Ridge, Knoxville area, from the academic side of the house all the way to very fundamental research on extraordinarily expensive and large science machines like spallation neutron source, all the way into actual manufacturing technologies. Last thing is a little bit of a plug. This Friday, there's going to be a meeting over at Pollard Auditorium in Oak Ridge, Partnering in Technology, sponsored by Y-12 in collaboration with the University of Tennessee. This is going to be a very technical meeting, but there's a lot of some of the topics that I've just very briefly brushed on in terms of technology, research and development, new things that we will be looking at over the next few years. This is just try to reinvigorate that environment. I don't think there's any question but what since the late 80s there had been a downturn at Y-12 and in the Oak Ridge area with staffing coming down into the Cold War. It looked like things were really heading into the dumper, that there really wouldn't be real need for facilities like Y-12. But I'm here to tell you, Y-12 has a very strong and viable future. Nuclear weapons are going to be with us for the foreseeable future. As long as they are, every individual weapon becomes even more important to our national security. So our ability to surveil it, analyze it, and return it to its original condition to be able to support this nation is even going to be more important. As I said earlier, the throughput of our plant has gone from just a few percent supporting the non-proliferation initiatives to this year it may actually outstrip the weapons side of the house. It's going to end up very close to 50-50. We're hiring new people. We're reinvigorating our relationships, not just with UT, but universities in general. Very active programs with minority education institutions and HBCUs in the area. And so this is, I mean, just overall for me at Y-12, this is just an extraordinarily exciting time. And Kathy, when we sat down and went over this, what did I forget to say?
Your personal experience when you graduated from NC State with your degree in nuclear engineering, you never thought what the future
was. Well, yeah, that was an interesting concept. I'm sure all of you folks in here are true scholars and just absolutely wonderful. It might, you know, I came from a very small school. I found the university environment to be very challenging. I think I had a 301 semester, but you know, that's better than none, I guess. You know, from probably the 7th grade, I decided I wanted to be a nuclear engineer, and I didn't even know what one was at the time. That was in the late 50s, mid-50s. You know, Nautilus was just being talked about. I guess Con Edison, the first reactor, came online, but for some reason, that's what I focused on. I never diverted. Went through high school, really enjoyed physics and chemistry and all that stuff. Went to NC State, did my 4 years there, and to get out in 4 years in nuclear engineering was an accomplishment in itself, even though my grades may not have been top in the class. They were, but But, I went to work in the shipyard in Charleston, overhauling and refueling submarines. And all my life, I had always read about the Manhattan Project and that, I don't know, just some mystique about that era, and the work was done, and I'd read about Y-12, and I saw us talking to a guy just the other day at the 60th anniversary of Y-12, Bill Wilcox, I think was his name, and he talked about in the original Manhattan Project, please don't quote me on the numbers, but it was something like, of the dollars spent, 60-some% were in Oak Ridge. It was like 20% maybe at Los Alamos and others. Everybody hears Los Alamos as the Manhattan Project, and they did all the design work. That's true, but the process of actually enriching the uranium and the initial fabrication, a lot of that stuff was done here in Oak Ridge. That was actually a sizable chunk of the budget. And in my wildest dreams, when I was a freshman in the sitting in the big auditorium and got the standard lecture, look on your left and right, and by the end of the time, there's only going to be one of you left, and that turned out to be about right. But the idea that I would actually be the site manager for one of the original Manhattan Project facilities was not, that wasn't even something I would ever even think possible. And so if you don't really limit your thinking, you're willing to move, you're willing to learn, never be satisfied with what you know, but always try to learn something new, you just never know where you're going to end up. And in the 3 years that I've been at Y-12, probably one of the most, I don't know if emotional is the right word, but I toured our old Beta 3 facility, which is, we still have one of the old Calutrons there, which in the earliest, the easiest way to think of it is nothing but a giant mass spec with a lot of current. But that was the original electromagnetic enrichment process. And to go down into the basement of that building, and I regret we just can't take anybody in there because it is inside our protected area, you find crates of capacitors and vacuum tubes, and they're addressed to Clinton Engineering Works. And these are things that were delivered, not quite 60 years ago, but probably 55 years ago. And to really just think, man, this is history. It is right there. So I've had a ball in my 3 years at Y-12. I'm looking for another several before I end my federal career. But I would just encourage anybody in today's world to think seriously about a long-term career in national security. It is clearly not for everybody. You have to have an absolutely impeccable record. We go through extraordinary clearances. Everybody has a Q clearance, and depending on where you are, there's a lot of stuff that goes beyond that. Some people view that as kind of an invasion of privacy, and we understand and respect that. And if that's your view, it's probably not the place you want to work. But if you're willing to put up with some of that stuff, the opportunity for the work we do, the precision to which we do it, is just absolutely remarkable. And I'm off the slides, but now I'm back onto my business card that I talk about, and I could go for a long time on that. So let me just wrap it up there and just open it up for any questions anybody may have.
Okay. All right. We got time for questions and comments.
Have to be, yes.
So how does your organization, NNSA, connect to the, what do you call it, the user, the people that make the missiles and all that? How is that integration done? I see that on your chart.
No, it's not. That's a good question. It's really done primarily through an organization we call the Nuclear Weapons Council. It actually has a little bit longer name than that, but it's a board that composed primarily of members from both the Defense side of the House, Department of Defense, and Department of Energy employees. The representatives to that are by our people in headquarters, and and basically the military gives the department the specs that they need to have met, and then it's up to us to try to deliver the product that meets that. Those people, including folks like Albuquerque, help with scheduling. That's the other thing that we find at Y-12. That most all of the employees, if not all, and same on my staff and federal employees, have an extraordinary sense of mission, because we know when we go look at a component, we can watch it go through the process line and see it be packed for shipment, and we know that in just the next few months that device is going to be sitting on a missile or in a bomb that we all absolutely hope will never ever be used, but it's also, we know that if it does, we got to make sure it works. So there's a real connection and sense of purpose, because we actually have a product we can see and we know where it goes. Yes?
Do you envision a plutonium mission at some stage at Y-12?
Probably not. Right now the plutonium mission seems to be for disposition. Is at Savannah River, and they've got a couple of facilities that are under consideration. I can't tell you exactly what stage, but basically two pieces of that. One, the disassembly and recovery of plutonium from pits, which are currently stored at Pantex, that being essentially the primary side of the house. And then the conversion of that material into oxide, which could be used in commercial fabrication so that then it can be burned. But right now, there would be no plutonium mission at Y-12 other than, just trace quantities, that kind of thing.
Any other questions or comments?
Yes.
Okay.
I was just curious as to what kind of opportunities you think would be available for someone who's in chemical engineering with a background in nuclear power work experience.
Actually, very strong. In fact, most of my people do not have nuclear engineering actual background or experience. Well, I say that. We have chemical engineers, mechanical, it all came out of, we got a lot of people from TVA, NRC. As I said earlier, our real focus is in manufacturing, recycle, processing uranium, all the way through the chemical processes, the ability to turn it back into purified metal, our machining, fabrication. We have a number of new projects underway, and we have people worry about seismic natural hazard phenomenon. I just can't imagine a discipline that we don't have at least one of at Y-12. Now, I say that on the contractor side of the house, BWXT Y-12, about 4,000 people. On the federal side of the house, currently I have 77, and we'll be going to 80. And those are in primarily technical disciplines, a number of nuclear engineers, chemical engineers, industrial. We have the whole gamut in our office. So we have to, the fundamental theory there is the federal government does not run the plant. We hire our M&Os and pay them a good fee to do that. But if somebody told me, if you don't know what's right, you don't know they're doing it wrong. So we have to be every bit as smart as they are, understand the processes, the technology, to make sure that they're doing it right. So, yeah, very broad. I can't think of a limitation of people that we're really looking for.
Okay.
Got to be some others.
Well, we do have refreshments. Well, here's a question, John.
Within that context of needs, what's the age curve? What are the prospects in the short term for your workforce being severely impacted by retirement and so forth? What are the dynamics?
The term that is often used, we have a very grading workforce. The number of people that will be eligible to retire over the next 10 years is scary. And so that's why we're pushing hard to recruit, particularly on the contractor side. And across DOE, my office is in a probably better shape than many. When NNSA was stood up in '99, there were 30 people, 37 slots, 30 people assigned to the site office. 10 of those left not long after I got there. And so out of that original 20, we've added about 55 to the staff over the last 3 years. And by and large, all those people were handpicked, and they were people that were interested in a challenge, didn't want to be bored, really wanted to learn, and just wanted to do something new. And so as a result, my office is probably, I have much fewer people approaching retirement compared to some of the other DOE site offices.
Okay, I do see several new faces in the audience, and those new people probably do not know that each week after our colloquium presentation, we adjourn downstairs for refreshments, and everyone's invited. But before we do that, let's express our appreciation to Bill for coming.
Thank you.
Thank you.
Good.
Excellent presentation.
And be downstairs if anybody has any other questions, feel like asking in a big audience.
Going down Texas. Down Bill Paul.
Okay. All right.